All right. Question 5 says determine the open intervals in which the graph of the function f of x equals x squared over x squared plus 625 is concave up or concave down. There's no way around these. You guys are gonna have to do the second derivative for that. So I'm gonna grab a different sheet of paper because otherwise I'm gonna have to squish it up. I had to write all over my little margins. So we had f of x equals x squared over x squared plus 25, I'm sorry, plus 625. And again, I had writing small, I had plenty of room on my paper. I just don't want to do that to you where you have to look at it like really tiny. Okay, so I'm just using a different sheet of paper. First derivative, what do I do? Guys, I need you to not talk. Okay. Quotient rule. So what's the derivative of the top? Times the bottom. Minus the derivative of the bottom times the top over the bottom squared. We're going to clean it up. We get 2x to the third plus 625 times 2, 1250 minus 2x to the third yes, thank you. Is everybody good? Your 2x cubes cancel out. You get 1250x over x squared plus 625 squared. Do your double prime. What is your derivative of the top? Times the bottom. Minus the top times the derivative of the bottom. So 2 x squared plus 625 to the 1 times 2x. All over x squared plus 625 squared. To the 4th, sorry, squared. What do I do now? That's what I would do while I'm doing the simplification. So everything all at the same time. So I'm going to show you that, but I don't typically write it for you guys. I'm going to take out the x plus 625, which will give me 1250 times x squared plus 625 minus 1250 times 4. I don't have a calculator. Somebody tell me what that is. I don't even have my derivative right on my paper. Yeah, 480 and then yes. 480 and 200. 5,000 x squared. And then this is going to go away. Over x squared plus 625. And I took one of them away, so I only have 3. So I got it. So it was 4, I took one away, it's 3. On the top, I have 1250x squared. What is 1250 times 625? Seven, 8, 1, 2, 5, 0 minus 5,000 x squared over x squared plus 625 to the third. What do I do now? We get 781250 minus 3750 x squared over x squared plus 625 cubed. Then what do you do? Mhm. And then? Mhm. So how do we do that? Mhm. And we get 0 equals 781250. And then? Sorry, I feel like I'm gonna sneeze. I apologize. Nose is itchy. 781250 is subtracted, negative 3750 x squared. What do I do now? Divide. Y'all are doing it perfect. Don't stress out. Everything is perfect. When I simplify this, I get 625 over 3. Then what do I do? When I square it 625, I get 25. And then square root 3. How do I fix this so it doesn't have a square root of 3 on the bottom? And then also don't forget that there are 2 answers, plus or minus 25 squared root of 3 over 3. These decimals are negative 14.43 and positive 14.43, which may help you with your intervals. Okay, so where's my intervals going to go from? Where should we start? Negative infinity to that negative 14. This pencil has been breaking all morning. Negative 14.43. What's your next one? Your next one. Good. Okay, so there's your values. You plug them into F double prime. So F double prime. What the heck is this calculator? Remember, we didn't have to simplify. It's right here. 781250 minus 3750 x squared over x squared plus 625 to the third. All right. What am I going to plug in? Oh my gosh, hold on, y'all. I'm sorry. Negative 15. What else? Make it easy. 0. Make it easy. You could do something else, but 0 and then 15. So sorry about that. My table. Negative 15, 0, and 15. Negative, positive, negative, negative, positive, negative. So what does this mean? This one is, and this one is. Okay, so we know our values are going to be either A or B because we have the 25 square root of 3 over 3. So negative infinity to negative should be concave down. So that eliminates A. And if we look at B, it says concave up, negative to positive, which is true. And then concave down, negative to the negative and positive to positive infinity. So our answer is which one? B. Everybody got it? All right, so again, this one is B. What do we do on this one? We have y equals 3x minus tan x from negative pi over 2 to pi over 2. First derivative is? Keep going. Minus secant squared x. Y double prime. Remember, this is the same thing as secant x squared. So your 3 is going to go away. You're going to have a -2. So the negative times 2 of secant x. And then what's your derivative of secant x? Good. So we can rewrite this as -2 secant squared x tan x. What is secant squared x? What is secant? One over cosine x squared. And then tan x. What are we looking for? Right, so in the interval negative pi over 2, what are we looking for? Where, what? Where it crosses what? We're looking for critical values, right? Where it crosses 0. Is everybody good? So I'm gonna change my window. We were right, negative pi over 2. I'm gonna put it in as pi over 4, not pi over 4. This one's regular pi over 2. I'm gonna put this in as pi over 4. -1 and 1, it doesn't really matter. We're gonna graph it. What's the only place it crosses? 0. So our critical value is x equals 0. So we're going negative pi over 2 to 0, 0 to pi over 2. What can we plug in? If you're not sure, stop. Oh my. Negative pi over 2 is -1.5. So I need a number between -1.57 and 0. -1. This one will be a positive 1.5. So what number can I put there? So we want -1 and 1 and not that. So what's at -1? Positive, and at +1 is a negative. So that means from negative pi over 2 to 0, it is concave up, and the other one is concave down. So concave up, negative pi over 2 to 0, and down 0 to pi over 2 is going to be E. On number 7, inflection and concavity, again, second derivative. So we have f of x equals x square root of x plus 16. Still going to do what though? Product rule. So f prime of x equals derivative of the first 1 times x plus 16 to the 1/2 plus the first times the derivative of the second one. And the inside is 1, so we don't have to put that, but I wanted to put it on there just so you remember. So we get x plus 16 to the 1/2. You have x on top. 2 times x plus 16 to the 1/2 on bottom. You can take the full derivative of this, or you can put it together. I would rather you put it together. So how would you put this together? What is your common denominator? So that gives us 2 times x plus 16 plus x over 2 times x plus 16 to the 1/2. Distribute 2x plus x is 3x. 16 is 32 times 2 is 32. Over 2 times x plus 16 to the 1/2. You can move the bottom up and do the product rule. You can do the quotient rule. It doesn't matter. I'm going to just do the quotient rule. Okay, whatever you like is perfectly fine as long as we get the same answer. All right. Derivative of the top times the bottom minus the derivative of the bottom. We have a 2, a 1/2, x plus 16 to the negative 1/2 times a 1, but also times the top. Looks like a lot, but it'll clean itself up nicely. And then 2x plus 16 to the 1/2 squared. Is everybody good? All right, clean up the top. I get 6. I'm going to rewrite it as a square root of x plus 16. Yep. Sorry. It's okay. Sorry. All right, next one. Your 2 and your 1/2 will cancel out. You'll have, sorry, a minus 3x plus 32 over the square root of x plus 16 all over 2 times x plus 16 to the 1/2 squared. And we can clean that up in a minute. I just want to focus on the top. What's your common denominator on the top? Not just x plus 16, but square root of x plus 16. So we're going to have 6 times x plus 16. We're going to have a minus 3x and a minus 32. I distributed that negative over the square root of x plus 16. all over 2x plus 16 to the 1/2 squared. Clean up the top, and also we don't divide, we flip and multiply for the fraction here. So we're going to talk about that at the same time. So we get 6 times x is 6x minus 3x is 3x. What is 6 times 16? (96 minus 32 is 64. Is everybody good? On the bottom, I have the square root of x plus 16. We're going to flip and multiply. What is 2 squared? And then we're going to have x plus 16. Why? Because the square and the 1/2. All right, the way that they will write it is 3x plus 64. And then x, 4 times x plus 16 to the 3/2. Very good. All right. So what do I do now? I set it equal to 0. What happens? I just get 3x plus 64 equals to 0, right? If I solve that, you guys see that on your paper anywhere? Why? There's going to be 2 reasons. We either did the derivative wrong, which I don't think we did, or what? Is that right? Good. There's no inflection points. The other reason is because we're doing x square root blah, blah, blah. Let me graph that for you. X, the regular function, x plus 16. Let me zoom 6. Hold on. It's all crazy. You guys see this graph? Let's look at, let's trace. Oh, sorry, that's not what I want to see. I just want to trace it. What is negative 64 over 3? Right. I just want to keep this up here while you do that so you can see it. Well, my graph stops at what? You see that? So why does this not work? It's not a value in the domain. Remember, we've talked about that before, right? So you didn't do anything wrong. It's just not a value in the domain. So we're not going to use that. But if we look at all our answers, they have zeros and negative 16s. Where would that negative 16 come from? If we have a negative 16 right here, if we set this in, what's going to happen? Going to give us a 0 in our denominator, whatever. But if we look at our graph, you guys will see that there's no inflection points. What do inflection points look like? Just like little curves, right? What do we have on this one? We have a minimum. So we're going to find that in the F prime, but we're not going to find it in the F double prime. So this actually does not have any inflection points. And then look at this graph. It says, so we can look at A or B, concave up on negative 16 to infinity or concave down. So if we went negative infinity to negative 16 to infinity, and we plug in, you're going to find that it's greater than 0 right here. So this is where it's concave up. What's wrong with this? What's going to happen there? Let's see. I'm gonna put my second derivative in, just so you guys can see it. 3x plus 64. 4 over x plus 16 to the 3/2. Look what happened when I put in a value less than -16. Because it's not in the domain. So you're gonna see that when you take the derivative, okay? So when you get that error, you know it's not part of the domain. That's why that doesn't work. But if I plug in a value bigger than -16, so I plug in 0, what do I get? A positive number, which gives me concave up. Does everybody see that? So that one's kind of weird. But again, square roots, remember square roots are like half graphs. It's only part of it. So it's not going to have either some of the negative values or some of the positive values, depending on which way it's turned. Okay. Number 8. Save your time. This one asks you find the point of inflection. So I'm actually going to graph this for you. 2 sine. Make sure my calculator is okay to do everything. I think we were good. No, stop. Mode is what I'm looking for. Okay. Graph it. I'm still zoomed out. It says the interval 0 to 14 pi. So I'm going to change my window. 0, 14 pi. And on this one, I'm just going to go by pi's. There'll still be a lot of lines. -1 to 1 because it's a sine graph. What is a point of inflection? What is a point of inflection? Right, so it's a point where things change, but it's still increasing or decreasing, so that doesn't change at all. But when we look at this, look between a maximum and a minimum. They're pretty much exactly between there. So when we're graphing this, you don't have to find the second derivative. Where would my inflection point be? Where's the exact point where it's between the maximum and the minimum? Right there where it crosses the x-axis at, if we went from 0 to 14 pi and it's in the middle, 7 pi. So your answer for that one. Sorry, let me go back to the last one was A for the people I'm recording for. 7 was A. And then on this last one, I just graphed. Oh, we already did it. D. I'm sorry, y'all. I didn't mean to go over one that I already did. All right. Number 9. Got plenty of room. I don't read my notebook anymore. Find all relative extrema of the function 2x to the 4th minus 32x to the 3rd plus 4. Use the second derivative test where applicable. So we're going to do that. What's your first derivative? Perfect. Second derivative? Is everybody good? All right. How do I solve? If I'm looking for min and max, what do I need to do? Do I even need to use the second derivative? No. Would we have to use the second derivative test? Maybe, but on this one, we definitely don't have to. All right, so we're going to look at this very first one. We're going to set it equal to 0. What do they both have in common? Which leaves x minus 12. So what are your two critical numbers? 0 and 12. Do we really have to do all of this? No, why? What are we finding? Max and min. So we know it's either going to be at 0 or 12, and we see that it's going to be at 12, right? So is it 12 negative 13,820 or positive? I'm sorry, y'all. So I should have read the question and just done it in the calculator. 2x to the 4th minus 32x to the 3rd plus 4. I'm gonna zoom fit just to make it be able to be seen. I'm gonna zoom out so you guys can see it. So what does this one have? It's a minimum, right? So it has to be which one? B. Again, we have not a max. We do not have a max. We do have a min. So the question is it at 12 or 24? Remember, you can do second trace. Min, left, right, middle. And there's your negative 382. 13820. Again, relative extrema, I don't have to do any work. We didn't already do this one. X to the 2/3 minus 6. We're going to graph. I'm all jacked up on my graph, but I'll get there in a minute. These are smaller numbers, so I'm going to zoom 6. What do I see? So we can go ahead and mark all the maximums because those are definitely not right. Where's your minimum at? You can see this one. That's it. Don't even have to do the work for it. That's already good. Okay. Don't make it hard. Sorry that I tried to make number 9 hard. I should not have done that. So just graph it. We did 11. We did 12. Now we'll go to 13. Your limits are not hard. One more time, your limits are not hard. We always divide by what? The highest power on the bottom. So we're going to take every single term and divide it by x squared because that's your highest power on the bottom. Plus 2 over x squared over negative 5x squared over x squared plus 4 over x squared. We see with negative 8 over x plus 2 over x squared, negative 5 plus 4 over x squared. And now we find the limit as it approaches infinity. Remember, anything with x or x squared on the bottom goes to 0. So on the top, we're going to have 0 plus 0. On the bottom, negative 5 plus 0. And then it doesn't matter because on the top we have 0. And your answer is going to be C. Any questions on 13? I think those are pretty easy. The next one's just a little bit harder because you got to do the square root, but it is exactly the same. Okay. Everybody good? All right. So the highest power on the bottom is x squared, but it's underneath a square root. So you got to do that on the top. So you're going to have 7x over the square root of x squared plus 6 over the square root of x squared over the square root of 64x squared over x squared plus 2x over x squared. And I just left it under the square root. It's going to be the same anyway. What is the square root of x squared? So those cancel each other out. And then what happens on the top? The x's cancel out. So we're just left with 7 plus 6 over the square root and the square cancels out. So x. Your x squares cancel out. So you're left with the square root of 64. And then one of your x's cancel out plus 2 over x. So on the top, I have a 7. 6 over x makes a 0. And then 2 over x makes a 0. 64 stays. What's the square root of 64? So your answer is A. Everybody good? No, you're fine. Everybody else okay? All right, we did 15, 16. We're at 17. A business has a cost of C equals 1.5x plus 500 for producing X units. The average cost per minute is C over X. Find the limit of C as X approaches infinity. So here's your formula. What's your formula for just C, not the C with the bar over it? And then it's divided by X. You can go ahead and clean this up. Separate it. 1.5x over X plus 500 over X. Your X's with your 1.5 will cancel out. What is the limit of 1.5? What's the limit of 500 over X? 0. So your answer is 1.5. Same thing, they just give you a formula and talk about how they got the formula, but it says just find the limit of S. So how do we find the limit as t approaches infinity of 81t squared over 12 plus t squared? How do we find that? Everything over t squared. So 81t squared over t squared all over 12 over t squared plus t squared over t squared. Our t squares cancel on the top. What is the limit of 81? On the bottom, our t squares cancel out, giving us 1. 12 over t squared, the limit is 0, and the limit of 1 is 1. So we get 81 over 1, or just 81. We did 19. We have 20. I feel like this is the only one that you might mess up. I think everything else should be okay. I think so. Remember, even your concave up, concave down, you can check on your graph. So check it on your graph, look at the intervals, whatever. But on this one, determine the slant asymptote. How do I determine the slant asymptote? Long division. I love how y'all say that with such enthusiasm. 5x squared minus 9x plus 5. Clearly on the top, you should have what two numbers? 5 and 4, right? Look at the top. So if you don't have anything other than that, I mean, you already started wrong. So how do I get x to look like 5x squared? A positive 5x, so that definitely eliminates these two. Distribute. We get 5x squared minus 5x. Change the signs to make them cancel out. And we get negative 4x, bring down your 5. X times what will give me negative 4x? Negative 4. So negative 4x plus 4, change the sign, we get a remainder of 1. The remainder doesn't matter. What matters is the stuff that's on the top. I want you to look at 21 for a minute. We know that A is our answer. Where's our point of inflection? Our point of inflection is at 0. So you guys know where it's at. Everybody understand? Everybody good? All right. We did 22, we did 23, we did 24, and we did 25. Any questions on this review? Everybody good? All right, so again, I'm gonna give you your test back. Look over 4143. You may start, you probably will not finish the next set, and that is perfectly fine. So everybody understand that. So I want you to pass your reviews up. I will give them back at the end of the class period. Don't forget, pass your reviews up. I just don't want them on your desk working on them. Make sure your name's on them. And then as soon as I get those, I'll pass your tests out and you guys can work on that. Uh-huh.